Now, let's go to the problem 50. 15, it says Arizona's Fantasy 5 is a 5 out of the 35 lottery. It differs from many other state lotteries in that its payouts are set. They do not vary with the field. To win the first prize, you must select all 5 of the winning numbers. To win the second prize, you must select any 4 of the 5 winning numbers. So that means you can have the 1 non-winning number in the second prize. To win the third prize, you must select any 3 of the 5 winning numbers. So you can have the 2 non-winning numbers. The first prize jackpot is the $50,000, but you paid $1 to pay, so you profit $49,999. Second prize pays the $500, and third prize pays $5. Find the expected value of the Fantasy 5. Okay, let's come back to the whiteboard. So, this is page 304, problem 50. First, tell me how many outcomes in this lottery. How many outcomes?
35 C5.
No, that is the number of the ways for choosing numbers. How many outcomes in this problem? If we talk about the expected value, we try to compute expected value. You know, when we play the roulette, we have only 2 outcomes, right? One is win, another one is lose. So now, 3? Which 3? First prize, second prize, third prize, right? Anything else? 4. Why is 4? Yeah, so the remaining case is lose, right? So if everybody win, then the lottery commission will lose, right? Will lose the money. So totally we have the 4 outcomes. Okay. So then let's look at each outcome. First one is the first prize, and let's get its probability. So the probability P, we know only 1 person can win the first prize. And totally, you have the 35 C5 ways to select the 5 numbers, right? So the probability of first prize is 1 over 35 C5. Very small. And let's get the value. Let me use a V for the value. The value is the 50,000 minus 1, so it's the 49,999. Since in the expected value, we need to multiply the value by the probability, and then we add the results, right? So now let's just first multiply this to P and V, and this guy is equal to 49,999 over the 35 C5. And you may use a calculator to compute this. And the answer is equal to 0.15401747 approximately. Now, let's look at the second prize. So the probability of second prize, you know, in the second prize, we have the 4 winning numbers and 1 non-winning number, right? So we need to select those 4 winning numbers out of the 5 winning numbers. The number of the ways for selecting these 4 winning numbers is equal to 5C4. And totally, how many non-winning numbers available? How many? It's the 5 out of the 35 lottery, right? Then how many non-winning numbers available? 30, right? 35 minus the 5 is equal to 30. You have the 30 non-winning numbers available. So now we need to select this 1 non-winning number out of this 30. Okay, so it's the 30 C1 that you multiply these 2 combination numbers. Then divide this guy by 35 C5. Then you get the probability of winning second prize. The value is the 500 minus 1, so it's equal to 499. Then P times V, this guy is equal to 5C4 times 30C1 over the 35C5 and times the 499. And this guy is approximately equal to 0.2305687. So this is the second prize. Now let's look at the third outcome. Okay, third prize. So the probability of winning the third prize, we know we need to select 3 winning numbers out of the 5 winning numbers, right? So the first part for the winning number part is the 5C3. And we need to select the other 2 non-winning numbers out of the 30 non-winning numbers, right? So this guy is equal to 30C2. Then divide this product by 35 C5. And also we know the value V for winning the third prize is the 5 minus 1, $4. Right. Now you multiply this to P times the V, and then you get the value. So let me copy the P again. So 5C3 times the 30C2 and divided by 35C5 and times the 4. And this guy is approximately equal to 0.05359915. Okay. Now, let's look at losing. How to find the probability of losing? You know, totally we have these 4 outcomes, right? And all these 4 outcomes are mutually exclusive. And together, they just make up the sample space. So the sum of the probabilities of these 4 outcomes should be equal to the probability of the sample space. That is equal to 1. So we have the probability of the first prize, I mean, just write the first, plus the probability of the second prize, and plus the probability of the third prize, n plus the probability of losing equal to what?